Hey, what's up guys? In this video I'll be covering vector mechanics for engineers, statics. I'll be covering chapter 2, statics of particles, and 5 problems, and I'll have them timestamped in the description. So for the first problem we have for the hook support shown, determine by trigonometry the magnitude and direction of the resultant of the two forces applied to the support. So in the diagram we have a hook and two forces applied. I just labeled them A and B just to differentiate the two forces. In order to solve for the resultant, we need to use vector addition. Just redrawing this, we have vector A, vector B, and the addition of vector A and vector B would give you vector R. And this is what we're solving for. We know that, let's say this is the vertical line. The angle between A and the vertical line is 25. And that's given to us. Another thing to note is between the vertical line and the vector B, it's 45. So that must mean the angle between the horizontal and vector B is also 45. That's why here we have 45 degrees. Finally, we know that since this forms a triangle, it will be a right triangle. And we know that a triangle is 180 degrees. If this is a right triangle, then these two angles has to add up to 90. 90 minus 25 would give you 65. So this angle is 65. So now we can solve for the vector R using the law of cosine. So we know that R squared is equal to A squared plus B squared minus 2AB cosine R. A is 200 squared plus B is 300 squared minus 200 times 300 times cosine of R. And R is the angle opposite of the resultant force. It would be 65 plus 45, which would give you 110. So now this is just simple arithmetic, and solving for this you would get R is equal to 413.57 pounds. So now we solved for the magnitude of the force. We just need to figure out the direction of the force. Alright, to find the direction of the resultant force, first we'll need to label some angles. We'll call the angle between the vector A and R alpha, and also the vector between the horizontal line and vector R beta. So alpha and beta. To find the direction, we'll also need to use the law of sine, which is sine of alpha over the magnitude B is equal to sine of the angle R over the magnitude R. Plugging in the values, we have sine of alpha over 300 is equal to sine of R, which is 65 plus 45, will give you 110, over what we solved for in the first part, which is 413.57. And now just solving for alpha, it'll give you 42.97 degrees. So now I want to solve for the angle beta. We know that beta and alpha has to equal to this right angle, 90 plus 25. So writing that as an equation, we'll get 90 plus 25 is equal to alpha plus beta. And solving for beta, it'll give you 115 minus alpha. So plugging in the value for alpha, you'll get beta is equal to 72.03 degrees. So here we have the direction of the resultant force. So now we could just rewrite this. It'll give you R is equal to 413.57 and the angle 72.03. So here's your solution for the magnitude and direction of the resultant force. So for problem 2, we have the hydraulic cylinder BC exerts on member AB a force P directed along the line BC. Knowing that P must have a 600 Newton component perpendicular to member AB, determine A, the magnitude of the force P, and B, its component along the line AB. So first of all, I'm just going to set up the forces. We have the length AB and the hydraulic cylinder BC. So in a lot of these problems, it depends on how you set up the coordinate system. In this case, I'll have the x-axis parallel to the length AB. So here we have the x-axis, and the y-axis is perpendicular to it. So now from the problem, we know that the force P is directed along the line BC. So here we have the force P. We can actually set up the x and y components of the force P. So here we have the force Px. Here we have the force Py. So now from the problem, we know that BC is 30 degrees from the ground. So if I were to make a horizontal line here, we have 30 degrees. Also, AB is 45 degrees from the ground. So now since PX and AB are parallel, this would mean that this is 45 degrees, and this is 45 as well. I'm just going to call this alpha, and we know that this is a right angle. So now doing some simple math, we know that 180 degrees is equal to alpha plus 30 plus 45 plus 90. So now solving for alpha, we get 15 degrees. So now we can go ahead and solve for the first part of the problem, the magnitude of the force P. This will give us cosine of alpha is equal to Py over P. Since we have two knowns, cosine of 15 is equal to Py, which is given to us in the problem, which is 600 newtons over P. Solving for P will give us 621.17 newtons. We can also go ahead and solve for the second part of the problem. We know that tan of alpha is equal to Px over Py. Tan of 15 is equal to Px, which is the component along the line AB, over Py, which is 600. Solving for Px is going to give you 160.77 newtons. So for problem 3, we're given, knowing that alpha is equal to 40 degrees, determine the resultant of the three forces shown. So this is a typical problem which you might be given. We have a block on top of a slanted surface, and it's important to know how to set this up to make your lives easier when you're solving this problem. So I'm gonna just redraw this. Here we have the slanted surface. We have the block. I'm just gonna draw the x-axis adjacent to the slanted surface, and it's going to be going through the center of the block. I'm also going to have the y-axis perpendicular through the center of the block. Here we have a positive x-axis, and here we have a positive y-axis. The reason why we have a rotated coordinate system is because it gets rid of the y component of the 60-pound force. So here we have 60 pounds. Here we have 80 pounds. And in this direction we have the 120 pounds. The angle here is alpha. Also the angle here is alpha. Second, we take the sum of the forces. The sum of the forces in the x direction would be equal to 60 plus cosine of 40 times 80 plus sine of 40 times 120 because the force is going in the same direction. And this gives you 198.41 pounds. The sum of the forces in the y direction is equal to sine of 40 times 80 minus cosine of 40 times 120 because the forces are going in opposite direction. And this gives you minus 40.5 pounds. So now the resultant force is equal to r squared fx squared plus fy squared. So substituting in the values, you get 198.41 squared plus minus 40.5 squared. And the resultant force, you get 202.5 pounds. So now we solve for the resultant force, and all we need to do now is find the direction of the resultant force. Finally, to solve the angle of the resultant force, I just broke up the x and y components of the resultant force. So in order to solve for theta, we use the equation tan of theta is equal to fy over fx. Taking the inverse of tan, we get minus 40.5 over 198.41. Therefore, tan is equal to minus 11.53 degrees. And finally, as a note, the theta that we solve for is for our coordinate system. So for problem 4, we have two cables are tied together at C and are loaded as shown. Determine the tension in cable AC and in cable BC. So first of all, I want to set up the free body diagram. So at point C, we have the weight, we have the tension CB, and also the tension AC. So we know that the weight is equal to mass times gravity. We know that the mass is 200 times gravity 9.81 is equal to 16.92 newtons. So now I can set up the force triangle. We have the weight going vertically down. We have tension CB and also tension AC. In order to use the law of sines, we need to determine some angles. If tension CB is 75 degrees from the ground, that would mean that this is 15 degrees because it's a right angle. And if tension AC is 75 degrees from the vertical line, this must mean that this is 15 degrees. So here we have 15 degrees. Also, if we have a right triangle here, 90 plus 75 would give you 165. 180 minus 165 would give you 15 degrees here. If we form another right triangle here, 15 plus 15 would give you 30. 90 minus 30 would give you 60. And finally, we can solve for this angle. 180 minus 15 minus 60 would give you 105. So now we have determined all of the angles. We can use the law of sine. We know that tension AC over sine of 15 has to equal to the weight over sine of 60. So sine of 15 is equal to the weight over sine of 60. We know that the weight is 16.1692 over sine of 60. If we solve for tension AC, we end up getting 586 newtons. We use the law of sine again for tension BC. We know that tension BC over sine of 105 has to equal to the weight over sine of 60. So sine of 105 is equal to the weight over sine of 60. Again, we know what the weight is, so solving for tension BC would give you 2190 newtons. For the fifth and final problem I'll be going over, we have two cables are tied together at C and are loaded as shown. Knowing that P is equal to 300 Newton, determine the tensions in cable AC and BC. First of all, I'm going to draw the free body diagram at point C. Here we have tension AC. Here we have point C. This is tension BC. Tension AC and tension BC are 30 degrees from the vertical axis. Here's our x-axis, and we also have a 200 Newton force going horizontally to the left. Finally, we have a force P going 45 degrees from the horizontal axis. So next, we need to find the sum of the forces in x and y direction. The sum of the forces in x direction would be equal to sine of 30 times tension BC minus sine of 30 times tension AC, because they're going in opposite direction. Minus 200 plus cosine of 45 times P. And this equals to 0. We can do the same for the sum of the forces in the y direction. And this equals to cosine of 30 times tension BC plus cosine of 30 times tension AC, because they're going in the same direction. Minus cosine of 45 times P. And this equals to 0. So now, since we know that P is equal to 300 newtons, we can solve for tension AC in terms of tension BC. So solving for tension AC would equal to And this gives you approximately 244.95 minus tension BC. So now substituting in the value for tension AC into the sum of the forces in the x direction, you get sine of 30 times tension BC minus sine of 30 times what we saw for in the first part minus 200 plus cosine of 45 times P, which equals to 0. Now we can substitute in the value for P and solve for tension BC. So now substituting in the value for tension BC into either of these equations, you can solve for tension AC. So there you go, guys. The tension BC is equal to 110.34 newtons. And for tension AC, it's 134.6 newtons. Alright guys, that's it for today's video. If you found this video to be helpful, be sure to like and subscribe, because that'll help out the channel a lot. In the next video, I'll be covering 3D problems from Chapter 2. Be sure to check that out. Thank you for listening as always, and I'll see you next time.